Today I'll be going over RL circuits that are source free. So RL circuits are circuits with resistors and inductors. So the equation for the current flowing through an inductor is I of L of t is equal to I naught times e to the negative r over LT. And this circuit right here is our first circuit we'll be solving for. We have a switch that will open up when time is greater than 0. So when the switch is closed, like down here, when time is less than 0, the switch is closed, and then we're under the DC conditions, and an inductor under DC condition creates a short or creates a wire, and what we're trying to find is the currents flowing through here, IL. So to get started, first we're going to realize that this resistor right here is being shorted because it's in parallel with a wire. So this resistor doesn't matter in our problem right now. So first we gotta find Req so we can find the current flowing out of here, denoted as I of S. So first we need to realize that the 4 ohm and 12 ohm resistor are in parallel. So that is equal to 3 ohms. So now our Req for when time is less than 0 is going to be equal to 3 ohms plus 3 ohms, which is 6 ohms. So then with that, we can solve for I of S, which is going to be 12 volts over our Req, which is 6 ohms, which is equal to 12, or 2 amps, I mean. This is just simple as Ohm's law. And now we're going to do current division to find I of L. So IL is going to be equal to, we're going to use the other resistor, which is our 12, plus our 4 plus 12 is going to be 16 times 2. It's going to be 12 over 8, which is going to equal 1.5 amps. And with that, we now know that I naught is equal to 1.5 amps. All right, we're halfway there, and then we're going to solve for when time is greater than 0. Here is the circuit for when time is greater than 0. Just going back to our main circuit, our switch is opened, so we don't need to include anything over here because there's no current going through it. So yeah, we just get rid of it. So now we're just left with this source-free circuit. So now we need to do is find like the other half of our equation of E is equal to negative R over LT. So now we're trying to find Req with respect to this inductor. So just looking at this circuit, we can see that current is going to come out of here, down the 4 ohm, and then up at 12, and then up here to the top of the inductor, and then the current is also going to go from down out the inductor across up through the 16 ohm resistor. So with that, Req is going to equal to 16 in parallel with 12 plus 4. This is going to be equal to 8 ohms. And now we can compute Req over L, which is part of our exponential, which is going to be 8 over 0.5 henries, which is going to equal to 16. Now we can finish our equation of the current through the inductor. So L of t is going to equal to our I naught, which we saw was 1.5 amps, times e to the negative Req over L, which we found was 16, times t. And that is the equation for this inductor. Also, the problem is asking us to find I1, which is this. I1. To solve I1, we can just do current division. So I1 is going to equal to it's going to be equal to 16 because all these are in series, because this is all I1 as well. So it's going to be equal to 16. Oh, we're using the other resistor, 16. And then these two, 4 plus 12 equals 16 plus 16 over 32 times IL of T, which our final answer is going to look like 0.75 times e to the negative 16t. This is the first problem done of the recitation slides. Here's our second problem. It is basically the same thing as last time, but we have a current source. So just like last problem, the switch will open up when time is greater than 0. So that means when the time is less than 0, our circuit becomes a DC circuit, and that means that the inductor will just become a wire. Another thing to note is that just because it became a wire, and that the whole left side of the portion of the circuit is now shorted. So that means we don't need it anymore because there's no current flowing through it, because all the current wants to go through the wire, which has the least amount of resistance. And now we're left with this super simple circuit. And to find IL is really just, we're going to do current division. So that is going to be our other resistor, so it's going to be our 40 ohms, over our 20 plus 40, which is 60, times 3. We cancel the 10s, make this a 2, and make this a 1, and now we have 4 over 2, which is equal to 2 amps. That is correct. So now we're about halfway done the problem, because we just need to find the E is equal to negative R over L of T. Here's our circuit for when time is greater than 0. So the switch remains open, so that means this whole half of the right side of the circuit is gone. We don't need it anymore because there'll be no current flowing through it because it's an open circuit. Now what we're looking for is we're looking for Req with respect to the inductor. So it looks like to me that it should be two parallel resistors. So it would be 20 ohms in parallel with 10 plus 20. So that's just going to be equal to 12 ohms. And now we want to compute R EQ over L, which is going to be 12 ohms over 2 henries, which is going to be equal to 6. So now we can finally write our equation, IL of T, and then be equal to our I naught, which we already found was 2 amps, is equal to 2, times e to the negative R over L, so 6, times T. There we go, and there's our equation. Here is our final circuit for source-free RL circuits. So in this circuit, the switch will open when time is greater than 0. So that means when time is less than 0, we have a straight wire. And also, since the circuit is connected by the wire, this becomes a DC circuit, and our inductor becomes a straight wire. And now with that, we know we want to find I of L. This will get us our I naught, or I of 0, part of the equation. So we just need to solve for it. So to do that, it's going to be a weird circuit division. So first we need to find I1 heading that way. So I'm just taking this from the slides because I don't feel like writing all this out. So we're going to do our other resistor, which is going to be our 4 over 4 plus this huge network over here. But to remember, this wire is in parallel with this 9 ohm resistor. So we also can just get rid of that and make our circuit a little nicer to look at. So now this is going to be equal to 4 plus 6 and 12 in parallel times our current, which is 5.4 amps. And that is going to get us 1.8 amps. All right, so now that we have I1, we now need to find IL. IL of 0 is going to be equal to the 6 ohm resistor over 6 plus 18. 6 plus 12 is 18, my bad. And then times 1.8. And that is going to get us 0.6 amps. So now that we have I naught, we now can solve for it when time is greater than 0. So that means our switch opens up, and we're just trying to find the equivalent resistance in respect to the inductor. Okay. So it's pretty easy to see that our Req is going to be equal to 6 plus 12, so it's going to be 18 in parallel with 9. And that's going to be equal to 6 ohms. And now we need just to simply put everything together so that our current flowing through the inductor when time is greater than 0 is going to be IL of t. It's going to be equal to our I naught, which we found was 0.6, times e to the negative r, which is going to be our Req, 6, over our inductance, so 0.5 henries, times t. And that's going to be, everything's going to be equal to 0.6 e to the negative 12t. There we go. And obviously our unit's going to be amps because we're working with current. And there we go. That is all 3 problems. And yeah, have a great day.